In this video, we're going to work on the ALEKS problem called naming and drawing carboxylic acids. There are two versions of this problem. This is one version. We have 3 molecules and we're being asked to come up with the name for each one of them. The other version of this problem will give you the name of a molecule and ask you to draw it. Let's do this one first. I think that one might be the easiest. So to name a carboxylic acid, we're going to find the longest continuous chain of carbon atoms that includes the carbon of the carboxylic acid. So I'm going to go with this right here. We have to include this portion of the molecule in the name, or excuse me, in the parent chain. Next, we're going to number that chain of carbon atoms so that the carboxylic acid starts at carbon number 1. This is kind of similar to aldehydes. This carbon of the carboxylic acid group is always going to be carbon number 1, and that's going to be important when we name the molecule. All right, so now we're ready to put the molecule's name together. We have a substituent on carbon number 2. It's a methyl, alphabetized as M. We have a substituent on carbon number 3. It's a hydroxy, alphabetized as an H. So this is going to come first in the molecule's name. We're going to start off 3-hydroxy. Then we name or locate and name our methyl, 2-methyl. And now we're ready to name the parent chain. This is a 3-carbon chain, so that would make it a propane, a derivative of a propane. To convert the name to a carboxylic acid, we're going to drop that last E, and we're going to replace it with oic, and then a space, and then the word acid, propanoic acid. There is a space here, and this is unusual because most of our molecules' names do not have spaces in them. All of this is just one big giant word, and then there's a space, and then we say acid at the end. Let's try another. Let's go ahead and do this one next. This one looks like it's probably going to be the hardest one. So we want to include the carbon of the carboxylic acid group, and then find our longest continuous chain of carbons. We'll go this way with it. Our carbon of the carboxylic acid group is always carbon number 1. Oh, I realize, as I said that just now, I realized that I missed explaining something in this last example, but I'll explain it in this example. To be clear, there's no mistakes down here. There's just something that I glossed over, didn't go into detail. Okay, so we've got 3 substituents. We have a methyl and a methyl and a chloro. Alphabetically, the chlorine is going to come first in the molecule's name because we're alphabetizing it. So we're going to start with 6. The location of the chlorine is on carbon number 6. 6-chloro. We have 2 methyls. One of them is on 4. The other is on 5. 4,5-dimethyl. And now we're ready to name the parent chain. It's a 6-carbon chain. A 6-carbon chain would be a hexane. But because it's a carboxylic acid, we're going to drop that E. Replace the E with OIC, space, acid. Now what I didn't talk about in the last video, or excuse me, in the last example down here, is that it is not necessary for us to give the location of the carboxylic acid group, the oic acid. So we don't need to say 1 hexanoic acid or 1 propanoic acid. Much like aldehydes, the carboxylic acid group is always on carbon number 1. That's the only place that it could ever possibly be. So we don't need to say where it is because there's only one option for its location, and that is carbon number 1. So we leave that part out. We leave the 1 out. Here's our last example. We're going to start with the carboxylic acid carbon, and then we're going to find the longest chain of carbons coming off of that, number that carbon chain so that the carboxylic acid is on carbon number 1. We have a hydroxy, a methyl, and a hydroxy. Hydroxy is going to come first alphabetically. 2, 4, dihydroxy. Hydroxy, 3-methyl. 5-carbon chain is a pentane. Leave off that last E and replace it with oic acid. Now what if you had the other version of the problem? The other version of the problem is where it gives you a name and it asks you to draw the structure. Let's just do this one right here. Let's say it gave us this molecule's name and it wanted the structure. I always like to start at the ending of the molecule's name. If I see propanoic acid, prop tells me that there are 3 carbon atoms in the molecule, and that propanoic acid part is telling me that carbon number 1 is a carboxylic acid. So I'll fill that part in. And then I can add my substituents. On carbon number 3, that's this guy out here, I have a hydroxy. And on carbon number 2, I have a methyl. And then this obviously is not done. The last thing we have to do is go through our carbon skeleton and make sure that every carbon atom has 4 bonds. Like this carbon here only has 3. That means there must be a hydrogen on that carbon, and our next carbon atom over must be a CH2.